All attendees are in
Hello.
listen-only mode.
Thank you very much for joining our webinar today. My name is Naro, and I'm the marketing manager of NetGuardians. Over the years that NetGuardians is a fintech company offering intelligent banking software, we have helped numerous financial institutions worldwide successfully for risk mitigation. Therefore, we have decided to organize this webinar to share our knowledge and experience. Now, I have the pleasure to introduce you to the person behind this innovative technology. And this is Jérôme Kehrli. He is the head of R&D of NetGuardians. Jérôme has 15 years of experience in software development for the financial industry. He's worked at different banks before joining NetGuardians. Now he continues his passion about innovative technologies and big data area, particularly here at NetGuardians. So you can always interact with Jérôme on Twitter using the Twitter handle that you see on the slide, that's Jérôme Kehrli. And he also animates the NetGuardians community by writing technology articles on our blog, which is called NG Fintech blog that you will be able to find on our website. And so don't hesitate to follow his blog articles as well. During the presentation, please, you can always ask your questions using the question box. And at the end of the presentation, we will try to answer all your questions if the time remains. If not, please do not hesitate to send us your remaining questions. And tomorrow you will be able to find all the slides that you will be seeing today on our website under the section resources. And I will be also sending you an email with the link. So now I let Jérôme continue with his presentation.
Thank you, Mine. Thank you very much for the introduction. Before starting, I would like to give you two quotes, right? The first quote comes from the Association of Certified Fraud Examiners in the report to the nation in 2014, and it says, banking fraud cost an estimated 67 billion in 2014. 70% of this was internal. Most remains undetected. I have a little issue with the presentation. It's better. So even though internal fraud is not something very openly discussed in banking institutions, it is a very important issue. And the second quote is from Gartner in 2014, and it says, the return on investment on big data analytics to solve fraud and security problems is less than a year. But using big data analytics to address fraud and regulation compliance related use case is not straightforward. A lot of so-called, big data innovation project or big data investigation project in banking institutions have either failed or lead to very poor results these last years. What I would like to do today is take some time to present why these projects tend to be more difficult than expected to implement and present our NG Screener platform and, more generally, our approach in regards to leveraging big data in financial institutions. So, just as I said it, a lot of big data innovation projects have simply failed, right, in the past years in banking institutions. That happens even in institutions with an existing extensive analytics platform and experience in the business intelligence domain. I would like to present quickly our observation in these regards. Even only 5 years ago, big data and NoSQL technologies in general were really confidential, right? They have been developed by the web giants and were really closely linked to web use cases. Now, of course, investments and very large retail banks were using massive distributed computing systems for a long time, working with some of the market's first technologies, mostly Teradata and the like. These big institutions are experienced in big data and know how to make it work for their large-scale needs. In the past few years, private banks and smaller institutions have in their turn become aware of the needs that big data can help them meet. But early technologies for distributed computing systems, such mostly Teradata, have always been far too expensive and complicated for their needs. The opportunity comes in the form of a big data revolution that has seen the emergence of dynamic and agile solutions that leverage big data for more targeted needs. And nowadays, most, if not all, smaller banks are launching or at least considering big data innovation projects and these technologies. These projects aim at identifying and implementing the most relevant solution for their needs. However, these smaller institutions have learned the hard way that implementing big data technologies, even with the recent technologies for fraud detection and compliance monitoring, is far from easy. There are a lot of challenges, right? But there are mostly two challenges that need to be addressed by banking institutions. First one is to be able to correlate data coming from different silos and normalize it. I mean, just being able to extract or capture the data is not enough. One needs to be able to correlate, normalize, and model the data. Second is the identification and implementation of business controls and use cases. Having a few ideas is good, but it's not sufficient. One needs to have a pragmatic approach to identify use cases and, of course, the required experience in both business and technology to know what works and what does not. I would now want to discuss these two issues in a little more details. The first difficulty is related to linking and normalizing data coming from different functional silos. I mean, in most banking institutions, right, the information system is implemented by a very broad set of different software components. You have the banking ERP or private banking ERP, a portfolio management system, the customer relationship management system, payments and order systems, accounting systems, governance, risk and compliance systems, e-banking platforms, mobile platforms, and so on and so forth. Financial institutions tend to underestimate the level of effort required to extract and normalize data from the various functional domains. The solution comes from a data collection framework, really DCF as we call it at NetGuardians, which is required to gather information from across the system. One needs to be able to rebuild consistent views of both transactions and user behavior paths across functional silos and individual components of the information system. The key terms here are normalization and modeling. The definition of a consistent and extensive data model for the data extracted from the information system is not optional, it's a must. The second difficulty is the underestimation of the required knowledge and experience in business, technology, and data sciences required to successfully identify and implement controls and other use cases. Many banks forget the importance of identifying business validation and analytics use case beforehand, as well as the very extended set of skills the implementation team has to cover. I mean, the team needs to be versatile in business and technology, but even further in data sciences. Nowadays, data science has become an engineering specialization on its own. In terms of use cases, the most basic ones for behavioral analysis are pattern-based intelligence. Further use cases go to predictive analytics through, profiling, advanced analytics, advanced algorithms, machine learning, and so on and so forth. The key approach here is to identify and define behavior patterns, keep business validation up to date on evolving risk and regulatory challenges, and of course implement best practices with regard to fraud and risk prevention. And then one has to address these with hundreds of controls and advanced algorithms. We'll get back to that. So, what I want to do today is present you with the best practices coming from our experience at NetGuardians. That experience comes from the development and deployment at customers of our NG Screener platform. So I thought before going any further with best practices and our feedback in general, I would like to take a few minutes to tell you about our NG Screener platform. I believe it makes sense to let you know what we are doing and what our platform is, because I think this can help you understand our legitimacy when discussing big data implementation best practice. So a few words on our platform from a functional perspective. We have two core applications. First one is the control execution framework, and second, the forensic analysis application. On the control execution framework and applications, controls are individual use cases covering very specific aspects of regulation or risk, such as for-height bypass, multiple logging on same IP. I'll get back to that. We provide hundreds of controls based on 3 different approaches: pattern-based intelligence, profiling, and advanced and predictive analytics. Controls can be executed continuously in real time or daily, monthly, yearly, whatever. The result of a control is a high-end, business-friendly report. We have various different types of reports which covers everything, from raw listings to high-end violation reports, giving all the context of a specific violation that occurred in the banking institution. In terms of end users application, we also have a control execution, administration, and development applications. And finally, we package a case management solution. The forensic analysis application is used to analyze and discover data, and as such, it provides, the usual analysis and discovery features, such as sum up, drill down, slice and dice to the data, filter and discover relationships in the data, and so on and so forth. It also provides the user with advanced analytics dashboard presenting key information regarding user behavior on the information system as a whole and all aspects, user, systems, whatever, involved in financial transactions. From an end-user perspective, all end-user applications are integrated within a full Web 2.0 graphical user interface. The forensic analysis application, control, user, administration, and development applications, and the case management application. Everything is reached from a web browser. Control execution results are high-end, business-friendly reports. These reports are available internally on the case management application we developed and integrate in our platform. That case manager supports typical features for such an application, such as resolution workflow, prosecution helpers, documentation features, etc. Report can, of course, also be exported through email, FTP, Samba shares, NFS shares, whatever. We package, again, I think I'll never repeat that enough, hundreds of ready-to-work out-of-the-box controls matching key regulations or fraud patterns. Controls matching a specific regulation aspect or risk concerns are packaged together in so-called Smart Control Objective, or SCOs as we call them. Then these SCOs are packaged together in so-called intelligence bundles, or IBs, matching specifically key regulations or risk management objectives. Our end users really select not the controls, but the objectives they want to cover. They focus on objectives, regulations, and assets to protect, not the technical complicated details of controls and their technology. From a data perspective, we work by extracting information from the banking information system as a whole. The key component here is our data collection framework, or DCF as we call it. Data is exported from the banking information system either continuously or at regular intervals. We offer all necessary tools and libraries to connect and retrieve data from the banking information system. A key specificity of NG Screener is that we consider the banking information system as a whole and consolidate the view of human activities and financial transactions across the various channels and layers where the actual, individual IT components are located. We rebuild the various IT components. We rebuild from the various IT components the consolidated view of both human activities on one side and financial transaction on the other side. In terms of details, we mostly work with audit trails and log files generated by the individual components. We also have lightweight probes that can extract specific reference information from business databases. And of course, we can go down, and we do it in some situation, to network sniffing should we need to. Finally, we have several user and administrator tracking systems, which I won't be discussing today. A last word on NG Screener regarding our technology. From a back-end perspective, we have developed our own discretionary big data technology, mostly in Java technology. The key software components on which our platform is built are Elasticsearch, PostgreSQL, and Hadoop. Our primary data container is Elasticsearch. This is where we store the data we extract from the information system. Thanks to our technology, we are supporting depth of analysis from days to years. It really depends on the size of the cluster the customer wants to consider. We really are in the scale out pattern, right? We size the cluster depending on the depth of analysis the customer wants to support. PostgreSQL and Hadoop are secondary data containers supporting the control execution framework. So, again, at NetGuardians, we have seen a lot of big data innovation projects simply fail at our customers these last years. On the other hand, we ourselves are continuously and successfully deploying our technology at this customer for some of these use cases. I would like now to share our experience in the field and what makes us successful. I would like to let you know what are our best practices and feedback when it comes to deploying big data technology for fraud prevention and regulation compliance monitoring. We note nowadays three distinct situations at our customers regarding fraud prevention and regulation compliance monitoring. First, some institutions are simply not considering a scientific approach to regulation compliance and fraud prevention. These institutions use manual validations from daily operation lists and enforce compliance checking by human validation. Second, most institutions have built these use cases within the BI or analytical platform. This approach is not bulletproof and suffers from, the usual intrinsic limitation of the BI world, which is the day-1 problem. We'll get back to that. Finally, some other institutions have understood the benefits of the most recent big data technologies in this regard. And they are launching innovation or investigation projects around, Elasticsearch, other NoSQL technologies, or Hadoop, of course, to support these use cases. I would now like to be discussing this approach and what makes us a step in advance on what banking institutions are doing nowadays. Regarding the reasons big data projects in financial institutions tend to fail, what are our lessons learned? First, I would like to present you our approach at NetGuardians in regards to the two usual issues in big data projects I have been discussing previously. On the first challenge, data linkage and normalization, the key approach here is to monitor user behavior and activities across all banking channels and layers. This data should be used to rebuild consistent views of human behavior across systems, as well as all human activities involved in the notion of a financial transaction. The key aspects here are as follows. First, the DCF or data collection framework. It's composed by libraries allowing the big data platform to gather information from nearly every component of the banking information system. The DCF should take care of data normalization and modeling. Modeling means correlate data to financial transactions and consolidate human behavior representation. Second, a strong understanding of the financial business and financial systems data model is of course required to do that. In our case, at NetGuardians, I would just like to do a little parenthesis and tell you a few words on what our 7 years of experience in the field allows us to achieve. On the core banking systems, we already know we get the data and make it ready for usage within a few weeks only. On other or new CBSs, those we haven't encountered so far, we can do it within 4 weeks, thanks to both our business understanding and technical mastery. We have nowadays more than hundreds of pre-built and working out-of-the-box connectors already solving the problem of fetching and normalizing data across functional silos. Usually, we are able to implement and configure connectors towards new systems in days, and that is regardless of the underlying technology or complexity. Normalization and modelization of data is, I believe, the utmost important aspect here. I cannot stress enough how important the notion of a data model is. One needs to be able to transform the partial data extracted from the banking information system and feed it in a data model versatile enough to enable the building of all the business control and use cases the platform needs to provide. And this is far from easy. And this is one of the reasons why a knowledge beforehand of the business validation use cases is required to be able to build a data model that will support each and every use case the big data platform will have to support in the end. On the second challenge, the underestimated business side, identifying use case for big data technologies and fraud or risk management seems easy, right? Everyone has plenty of ideas. But coming up with meaningful use cases, having an actual added value, is more difficult. One needs to be pragmatic on one side and benefit from a very strong knowledge of both the finance business and big data technologies on the other side. Yeah, maybe I just give you a few hints in this regard in a raw fashion. First, start small. Always start small. Identify one very strong use case and implement this single one completely in an industrialized fashion. A very strong use case means that it should be both simple to implement and provide out of the box a strong added value. The lessons learned from this first exercise will be invaluable. Identify best practices in the field. Discuss with fraud or risk experts. They are in the best position, even your own, right, in your bank, fraud and risk experts. They are in a unique position to let you know what are the controls they do manually, and a very good first start will be to automate these controls. Match controls with key regulations. Find out requirements of regulations and implement the corresponding controls. This is straightforward, of course. Regulations are very well detailed in terms of what controls should be implemented. Get in touch with your own audit and controls teams. And of course, and I cannot stress enough as well how much is important, don't jump to very advanced machine learning techniques so quickly. Best results in the field comes from a much more pragmatic approach. We'll see that soon. And yet, of course, machine learning can be interesting for some other specific use cases.
Before moving, Jérôme, we just have a question related to this point. There's a question about what kind of controls do you have for the banking level from the business side? Could you give some examples of controls that we have in place?
Yeah, I had some examples in the next slide because I can already go on. We have three types of controls, right? Pattern-based intelligence, profiling, and predictive analytics. On the pattern-based intelligence, we really search for the audit trails, for specific, behavior schemes. One example is multiple logging from same IP. We search in the audit trails if situation occurs where two different users, business users, right, have been working on the same machine in a very short period of time, in which case it is a good indication that a user logged out with his old credentials, logged back in with different credentials to validate a fraudulent transactions. This is one of these patterns that we have implemented, and we are looking continuously in the audit trails. And we have 100 different of such controls, hundreds different of such controls. Another example is the 4 eyes bypass. We look at every financial transactions and search for the input and validation trails. And if it appears that the inputter is the same user than the validators, then it is clearly a violation of the 4 eyes checks, that is used in banking institutions. So this is another example of a control we have, right? On profiling, I have some slide about that, but maybe a few words in advance. On profiling, what we do, simplest example is we look at the countries where, for instance, a user is issuing mobile operation. If we find out that in the 6 last months he has always connected to the e-banking platform in Switzerland, in France, and in Germany, for instance, and suddenly we have a connection on his account on the e-banking platform coming from, I don't know, Nigeria or Brazil, we raise an alert because it's something completely unusual considering his profile. On advanced analytics and predictive analytics, we mostly do two things, which is, risk scoring and abnormal behavior detection. And I'll get back to that in a moment, if that is fine.
Okay, perfect. Thank you.
You're welcome. So yeah, pattern-based intelligence. I already told you a few things. Pattern-based intelligence consists in searching for well-defined behavior schemes or patterns in the activity trails. Look at fraud events in the past, discuss with regulators, audit, compliance officers, and find out about what control they operate, discover best practices in the field, and design the corresponding behavior scheme. Then implement a control on top of your control execution framework that search for this behavior scheme in the activity trails. Again, discussing with regulators and fraud experts is a very good start and can help come up with dozens of initial patterns to implement on the system. The control execution framework should provide all the primitive operations for behavior analysis and data correlation. At NetGuardians, we have capitalized on our business understanding and technology mastering to identify such patterns and implement them in controls hundreds of controls. And yeah, I already gave two examples, right? The 4-eyes bypass and multiple slugging from same IP. Simplest example one can think of and very easy to implement. Profiling. Pattern-based intelligence is rock solid and bulletproof, but sometimes it's not sufficient. Sometimes it is required to identify unusual situations without any formal knowledge of what such a situation can be. In this regard, profiling is a must-have. It consists in looking at past activities around, either an account, a customer as a whole, or an internal user, even a portfolio, right? And build metrics identifying what he is usually doing. For instance, in the case of a customer, his profile should capture his usual, money inputs and outputs of capital on a daily, weekly, monthly, or yearly basis, what channel he is usually using, such as e-banking, mobile, phone calls, even what type of transactions, what are the usual countries of origins of his orders, the usual countries of origins of the counterparties he is working with, and so on and so forth. All this information is captured in his customer profile. Then, every activity deemed as sufficiently outside of his profile, hence unusual, right, should raise an alert, such as, for instance, an important cash withdrawal from an ATM in a country the customer has never visited before. Profiles should be built, again, at least at account, customer, and user level. Pragmatically, profiles take the form of a set of statistical metrics on a set of predefined dimensions. At NetGuardians, we have developed a profiling framework enabling our customers to define profiling dimension and use cases in a very flexible and user-friendly manner. And this is a must-have for profiling because users will discover, the banking institution will discover the right way to build a profile only with the required experience. They will change their mind, they will change the dimension, they will change the metrics that are used continuously. So the framework needs to be flexible and user-friendly. On the same ground that the profiling application, we are working on more advanced techniques aimed at leveraging most recent machine learning techniques to achieve predictive analytics. Predictive analytics and machine learning techniques applied to fraud detection in general is very, very difficult to implement. Most recent work and studies in the field show that avoiding a failure of such projects due to the very high rate of false positives is tricky. At NetGuardians, we have experience in the field and we know what works and what does not. And while there are certainly no magic silver bullet here, there are some approaches that work well and provide added value to our customers. There are two approaches that are working pretty good. First one is risk scoring, which consists, in weighting characteristics of a transaction, of a profile, of a customer to compute a global risk score. Then, if the global risk score exceeds some trigger, the transaction or whatever piece of information or order, right, is deemed as a violation. Behavioral change detection is something more tricky. It is kind of looking like profiling, but what profiling is really, building of metrics. Behavioral change detection goes much further and in dynamically identifying consistent changes in behavior of a customer, a portfolio, an account, a user, whatever. And this is the place where machine learning, most recent machine learning techniques can have a striking added value. But it is very difficult to avoid a very high rate of false positive. Okay, so pattern-based intelligence, profiling, and advanced analytics covers our algorithmic approach at NetGuardians and what we believe works best regarding fraud prevention and risk monitoring use cases. Now another topic. As discussed, we have seen a lot of situations recently where the use cases we are working on at NetGuardians are actually implemented at our customers on the analytical platform, the BI world, right? This seems quite non-optimal to us, and I would like to discuss this a little further. Maybe before, just a little view on typical financial institution IT landscape. That the IT landscape in financial institution is usually separated in two worlds. The first world is the transactional system, also known as the operational systems. This is where users input transactions and orders. And the second world, of course, is the analytical system, also known as BI or business intelligence. The transactional system works most of the time in straight-through processing on the database or on the market. It is qualified as an online system where users perform actions and get answers immediately. The analytical system, on the contrary, is an offline system, working most of the time in batch mode and producing reports and KPIs. The analytical system works by extracting activities and data from the operational system. These extractions happens most of the time during the night. Why? Because it happens when the system load on the operational system is low. It works in batch mode and runs during the night in order not to add load on the transactional system during working hours, not to decrease the performance of the systems when actual users are connected to it. Then, once all the required data has been extracted from the transactional system, the analytical system generates reports, computes KPIs, does its business, right? Thus, if you look at the analytical system, and if you consider BI reports, most of the time they are always at day -1 frozen vision. They always show the situation as of yesterday. At best, they are 1 day late. Sometimes they are even 1 week or a full month late. Aside from computing up-to-date KPIs, again, fraud detection and pattern detection of operational activities in general are addressed by BI use cases for a long time. But the -1 day problem is at the very root of the difference between the operational world and the analytical world. The analytical world, again, is always 1 day late at least in comparison to the operational system. When it comes to fraud detection, and even worse, if you consider fraud prevention, working 1 day late is simply way too late. Now imagine, what if we could execute typical BI use cases online in the operational world instead of in batch mode? What if we could do that without impacting the load of the operational system in any way? This is actually what we do at NetGuardians. We make typical analytical use cases for fraud detection and compliance regulation monitoring enter the operational world. We make them real time. Our platform is plugged transparently on the operational systems, and we perform online close to real-time analysis. We detect fraudulent behavior and compliance violations at the precise time they happen, not the next day. We can go as far as implementing fraud prevention systems instead of only late fraud detection. We can flag a transaction as fraudulent or risky within minutes after it has been validated, not the next day, which again is way too late. A last word on some specificities we have at NetGuardians. And it is that the NG Screener platform can act as a data provider for financial institutions' own BI or big data platform. And this is quite important. We have adopted an open architecture approach that enables us to solve both problems presented in introduction in a definitive manner for our customers. We can really act as a bridge for our customers who have their own Hadoop or NoSQL system, by enabling these platforms to integrate deeply and completely with our own. Of course, we are compatible with most, if not all, Hadoop storage system, HDFS, MapR, in the future MongoDB, Cassandra, whatever, and yeah, in general, NoSQL technologies out there. Our own, specifically on Hadoop, our own technology and Hadoop not only integrates well with each other, but are really complementary. So what does that mean? They are able to work in a true cooperative mode. Data does not need to be passed back and forth between both systems. We provide connectors enabling PIC scripts, Hive request, or Spark request to fetch data directly from within our own storage. On the other way, we are able to query Hadoop data natively and to use it in our own system without prior loading of this data within our own technologies. This means that should the banking institution wants to deploy its own big data infrastructure to cover use cases out of our mission, we still have a striking added value since we can act as the data provider for their own platform. Well, this closes my presentation for today. I would like to finish by saying that we are working in the world of big data concerns for 8 years now. We have lived the big data revolution from the beginning and are working with specific big data technologies, especially Hadoop and Elasticsearch, since pretty much the very beginning of these technologies. I believe that considering our product is simply a natural approach when a banking institution wants to leverage big data technologies for fraud prevention and risk management. Now, of course, other than that, we would be very happy as a company if we can help anyone successfully implement these technologies on its own. And if, our experience can benefit others. So don't hesitate to contact us on Facebook, LinkedIn, Twitter, or else, or even contact me directly on the same media. Thank you very much.
Thank you, Jérôme. So we have a few questions that we can take. We have a few minutes left before the end of the presentation. One question is about the rate of false positives. That's an interesting question.
Yeah, it's a very good one. There have been, in the past 3 years, I mean, most banking institutions I have been in touch with were really considered, because you can read so many things on internet about what machine learning techniques brings for fraud prevention and, regulation, compliance monitoring. And you can see a lot of successful stories on internet. So banking institutions tend to believe that it's easy. So they start, extracting data from the information system and try to prototype many machine learning techniques to do predictive analytics or abnormal behavior detection on their data. And this works somewhat, but the issue is that very soon it is very difficult to make the system learn what is actually an actual abnormal behavior, what is actually a real violation. And these systems most of the time end up raising alerts on things that are unusual but are not abnormal, that not actual issue. They are a legitimate change of behavior, a legitimate exceptional situation for the customer, the account, the user, whatever. And at the end of the day, such systems make the risk officer or compliance officer spend a lot of time investigating normal situation. And then, of course, these officers want to get rid of the system and they don't want to hear about it anymore. And this is what happens most of the time. And it requires a big deal of experience in financial business and data sciences to be able to build a system using machine learning techniques that doesn't raise too many false positives, that really only raises alerts on cases that are actual violation, actual fraud, actual abnormal behavior someone really needs to investigate.
Okay, thank you very much. Hopefully this should be clear now. We have another question regarding the predictive analytics. So the system could be able to predict, but what will it be able to predict exactly? In short, BI is being integrated in the system. That's the question.
Yeah. Abnormal behavior detection. One example I can give you is the following. Very often, I'm speaking about internal fraud, right? In this case, very often when a fraudster commits a fraud, he starts days or weeks earlier to behave suspiciously. For instance, he starts browsing dormant accounts, investigating them, listing transactions, inquiries, information about the owner of the dormant account. He starts to do things that are not normal in his, day-to-day job. I mean, someone from back office, from I don't know what, payment department, when that guy starts looking at dormant accounts and trying to get information on these accounts, this is not part of his job. It will be part of the job of someone from compliance, or middle office. It is not part of the job even of a portfolio manager. A portfolio manager accesses his own accounts, the accounts of the customer is tracking, not any kind of account in the bank, and specifically dormant accounts. So in the specific case of dormant accounts, when a user commits a transaction, a fraudulent transaction of the dormant account, you can spot that using usual pattern-based intelligence. But using predictive analytics, you can go much further. As soon as a user starts to do things that is not normal for him, that he has not been doing previously, like discovering dormant accounts and querying information on this account, you can raise an alert. And you can raise that alert not only way before the fraud is committed, but you can raise the alert even sometimes before the fraudster convinces himself to actually attempt a fraud.
Okay, and we have another good question. I think this should be our last question looking at the time. Do you have a modeling technique for pattern-based intelligence, or do you study the actual fraud patterns on the data manually?
It's a very good question. So speaking of modeling, I can understand the question in two ways. I will try to answer two ways. First, with pattern-based intelligence, half of the time we really discover a new fraud event and understand the pattern or the behavior schemes that made it happen, and implement the corresponding control. And the other half of the times, it is our fraud experts that can foresee a weakness in a system, and we implement a detection of the activity, a detection of the behavior scheme before having encountered the fraud at a customer. In terms of how we model the user behavior that goes around the fraud, that made the fraud happen, it's really manual. We have the experts that know both the technology, the core banking systems, the data, and of course the finance business, and they help us understand how and why we should check the data and what we should check in the activity trace. So it's really a manual approach. And then one other way to understand this question is speaking of the data model that we have to build on the big data platform to integrate the data extracted from the banking information system. And here as well, there's really no magic silver bullet. It requires a lot of experience and a lot of refinement to finally come up with a data model, flexible and versatile enough to be able to put any kind of controls and any kind of use case in it. I mean, as long as it's related to fraud prevention and a regulation compliance monitoring. So I would say a good approach for someone who will start from scratch is, again, find out, discover a very strong use case, meaning it's simple to implement and yet has a striking added value. And when you will be implementing this use case, you will model the data in the big data platform in a way that will give you an initial model. Then try to find two completely different use cases, ideally using completely different techniques. And these two other use cases will force you to refine the data model in a way to help it cover these other use cases. And this will give you a good starting point to understand what this data model is, what it should be, and how to make it evolve. But let's make no mistake, let's be honest here. This data model will continuously evolve before reaching the required maturity to support additional use cases without additional changes. That takes years and hundreds of use cases.
Okay, perfect. I think now we are running out of time. So thank you, Jérôme. I hope you all found it insightful. And I think the questions were also very good, and it really helped to complement the presentation. Thank you very much for all attending our webinar.
Thank you, guys.
And thank you for your questions. So we look forward to seeing you at our future webinar. So keep looking at your Facebook accounts, LinkedIn, and Twitter, and we will be able to communicate you soon also the link for the slides. You will be able to find them on our website. So thank you very much. We wish you all a very nice day.
Goodbye.